In this lesson, we're going to look at section 3.6, polynomials of the form ax squared plus bx plus c. In this lesson, you will learn how to extend the models and algebraic strategies to multiply binomials and to factor trinomials. In our first example, we're going to multiply binomials using the rectangle model. We used this model before when we multiplied a monomial by a binomial, so the process here is the same, except that we have an extra row now. So you're going to put one expression along the top and the other one along the side. So it doesn't matter which expression goes where, as long as the expression in the bracket stays the same. So you can't switch them up. It has to be ones that are already together. So 3n subtract 5, it cannot be 3n subtract 7. So along the top and along the side, we're going to multiply. Starting off the top left-hand corner, 4n times 3n gives us 12n squared. 4n times negative 5 gives us negative 20n. Negative 7 times 3n equals negative 21n. Negative 7 times negative 5 equals positive 35. So once we do that, as you can see on the right side in our algebraic steps, you're going to group the terms from the highest degree of exponent 2 to the constant term when the degree is 0. And as you can see in the rectangle model on the diagonal, we have two similar variables, n and n. So we're going to group those together, and we're going to combine those like terms, so that we have a solution of 12n squared subtract 41n plus 35. Next, we're going to look at factoring a trinomial by decomposition. Decomposition is a new procedure. We haven't used that before. And you have to keep in mind, in our previous lesson, we did factor a trinomial of the form ax squared plus bx plus c. But our coefficient of a had to be equal to 1, or if it was greater than 1, we had to remove the greatest common factor so that the trinomial left in the bracket would have an a equal to 1. However, this is not always going to be the case. You're going to have questions where your x squared term is going to be greater than 1, and you cannot factor it the greatest common factor. So the method of decomposition is an inverse procedure for multiplying binomials. The trinomial is decomposed by replacing the middle term bx with two terms whose integer coefficients have a sum of b and a product of ac. The two brackets that we have when we do our removing of the greatest common factor, they have to be the same. And when you see your factors that you have left over, the two brackets will be the same, which will be one factor. And what you remove as the greatest common factor will be another factor. So what we're going to do now, we're just going to look at an example to clarify what this all means. And we're going to look at 8x squared subtract 18x subtract 5. So our very first step, you're going to take your a and your c term and you're going to multiply those. So you're going to go 8 times negative 5. That will give us negative 40. After a trial and error, we have a product of negative 40, but that has to satisfy a sum of negative 18. So negative 20 and positive 2 does satisfy the negative 40 product, and once you add those, you will get negative 18. So you're going to leave your a squared term, your ax squared term the same, so you write down 8x squared, but you're going to start off with your highest factor, so you're going to start off with your 2x. Then you're going to write negative 20x and leave the constant term the same of negative 5. You're going to group two terms together, so you're going to group the 8x squared plus 2x, and then you're going to group the negative 20x subtract 5. In our third step, you have to remove the greatest common factor, and the greatest common factor does not have to be the same for each bracket. They can be different. You're going to look at each bracket on its own basis. So we removed a 2x from the 8x squared plus 2x, and that leaves us with 4x plus 1. So since we have 4x plus 1 in that bracket, somehow we need to remove a factor so that the second bracket becomes the same. And we can remove negative 5 from negative 20x subtract 5, and that will leave us with 4x plus 1. In our final step, we have our two factors, and how we got this, you use the greatest common factors that you removed, so 2x subtract 5, you combine those and make that one factor. And the second factor is what is left over in those two brackets that are the same, 4x plus 1. So if you want to verify the solution, you could easily multiply or use the distributive property to verify that you get 8x squared subtract 18x subtract 5 back. If you don't like using the algebraic method, you can look at the rectangle model using decomposition. You're going to write your x squared term in the left-hand corner, your constant term in the bottom corner, and the factors that make a product of negative 30 and a sum of negative 7 in the diagonal. Once you do that, you're going to look and see what is the greatest common factor you can remove from all the rows and all the columns. And so once we do that, you can see that you can take it an x and a minus 2 or a negative 2 on the top. And along the side, we have 5x and 3. So our two factors there will be 5x plus 3 and x subtract 2. Now, this is in our summary. When factoring polynomials of the form ax squared plus bx plus c, there are three rules. If a is less than 1, or a is equal to 1, write the factors as a product of two binomials. If a is greater than 1, factor at the common factor first, then write as a product of two binomials. If a is greater than 1 and a common factor cannot be removed, you have to use decomposition. And the rectangle model can be used for decomposition as a visual representation.